Welcome to the course on Python for data analytics, machine learning and generative AI. In this video, we are going to learn about strings in Python from foundation to mastery. In this video, we will cover what is string, assessing string with indices, the art of slicing, concatenation, repetition, common transformations, method reference, the power of f-string, handling special and illegal characters. Strings are one of the most fundamental data type in Python, and at the same time, they are one of the most powerful tool you will use in real world programming. The goal here is not just to memorize syntax, but to truly understand how strings behave, why Python treats them the way it does, and how to use them efficiently and confidently. So let's get started and build a strong foundation in Python strings. A string in Python is an immutable sequence of characters. In simple terms, a string is text enclosed within quotes, either single quotes, double quotes or triple quotes for multi-line text. Now, the most important concept to understand about string is immutability. Immutability means once a string is created, it cannot be changed. Even if an operation looks like it's modifying a string, Python is actually creating a new string in memory, leaving the original one untouched. This design makes strings safer and more predictable when working with data. Let's look at some examples. Here, S1 is created using single quotes. Next, S2 uses double quotes. Functionally, both are the same. You can use whichever is more convenient. Finally, S3 shows a multi-line string created using triple quotes. Multi-linked strings are especially useful when working with long text documentation or formatted output because they preserve line breaks and spacing. Every character in a Python string has a specific position, which we call an index. Because strings are ordered sequences, Python allows us to access individual characters using these index values. Indexing always starts from 0 on the left side, so the first character has an index of 0 and the second has an index of 1 and so on. Python also supports negative indexing, which means we can count character from the right side starting with -1 for the last character. In this example, we have the string hello world. If we access index 0, Python returns the letter H because that is the first character. If we access index -1, Python returns the exclamation mark, which is the last character in the string. We can also jump directly to any position we want. For example, accessing index 4 gives us the letter O. This indexing system makes string extremely flexible and powerful, especially when working with text data. However, it's important to remember that indices must be integers, and trying to access a position that does not exist will result in an index error. Understanding indexing is a key foundation for mastering string operations in Python, and it will be used repeatedly in slicing, looping, and text manipulation. Slicing in Python allows us to extract a specific portion of a string with precision. The syntax for slicing is string square bracket start colon end, where start is the index where we begin and end is the index where we stop. But importantly, the end index is not included in the result. In this example, we are working with the string hello world. When we use the slice b of 2:5, Python starts at index 2, which is the first letter L, and continues up to index 5, stopping just before it. As a result, The extracted substring is LLO. Python provides convenient slicing shortcuts that makes working with strings even easier. In many cases, you don't need to specify both the start and end indices. When you omit the start indices, Python automatically begins slicing from the start of the string. For example, using b square bracket colon 5 extracts characters from index 0 up to but not including index 5, giving us the word hello. Similarly, when you omit the end index, Python slices all the way to the end of the string. Python allows us to perform advanced slicing using negative indices, which is especially powerful when the information we need appears near the end of a string. Negative indices count backward, starting with -1 for the last character, -2 for the second last, and so on. In this example, we work with the string hello world. By slicing from -5 to -2, Python starts at the letter O in the world and stops just before the letter D, resulting in the substring ORL. In Python, strings are immutable, which means once a string is created, it cannot be changed. Instead of modifying strings, we build new strings by combining or repeating existing ones. Python makes this easy using two operators, the plus operator for concatenation and the asterisk operator for repetition. Let's start with concatenation. Concatenation simply means joining strings together using the plus sign. In this example, we take the string hello and the string world, add a space between them and combine them into a new string. When we print the result, we get hello world. Next is string repetition using asterisk operator. This operator allows us to repeat a string multiple times. Here, the string hello is repeated 3 times, producing the output hello, hello, hello. Notice that Python repeats the entire string exactly as written, including spaces. Python provides a powerful toolkit of building in string method that allows us to transform text easily. One very important point to remember is that strings in Python are immutable. This means none of these methods can change the original string. Let's begin with changing case. Using the upper method, we can convert all character in a string to uppercase. For example, when we apply upper off to hello world, the output becomes hello world in capital letter. Similarly, Python also provides lower off if you want everything in lowercase. Next, we have removing extra white space. The strip off method removes unwanted spaces from the beginning and end of a string. This is extremely useful when working with user input or data read from files. After applying strip off, the text becomes clean and ready for further processing. Another commonly used transformation is replacing substrings. With the replace method, we can substitute one character or word with another. In this example, replacing the letter H with J changes hello world into jello world. This is very helpful for text corrections and formatting. Finally, let's look at splitting strings. The split off method breaks a string into a list based on a chosen separator. When we split hello world using a comma, Python separates it into two elements, hello and world. This method is widely used in data processing and analysis. Beyond basic string operations, Python provides a wide range of built-in methods that help in transforming text, handling white spaces, searching content, and inspecting string properties. The first category, casing and transformation, focuses on changing the appearance of text. Methods like capitalize, lower, upper, and title help control letter case, which is especially useful for formatting names, title or user input. The swap case method reverses the case of all characters, providing flexibility when manipulating textual data. Next, the whitespace and alignment methods deal with cleaning and formatting strings. Functions such as strip-off, isStrip-off and rStrip-off removes unwanted spaces, which is common when handling user input or reading data from files. Alignment methods like center-off, ljust and rjust helps position text neatly, making outputs more readable, especially in tables or formatted displays. The searching and counting category helps locate and analyze content within strings. Methods like countoff, findoff, rfind allow programmers to check how often a substring appears and where it is located. The starts with and ends with method are particularly useful for validation tasks such as checking file extensions or input patterns. Finally, the inspection methods perform Boolean checks on strings. Functions like isAlpha, isAlNumoff, isDigit and isSpaceOff verify the nature of the characters in a string. Similarly, isLower and isUpper confirms the case of the text. These checks are essential for data validation, ensuring that input methods the required format before further processing. Overall, this slide highlights how Python string methods provide powerful, readable, and efficient ways to manipulate and validate text in everyday programming scenarios. In Python, we cannot directly concatenate a string and a number using the plus operator. Doing so results in a type error, as shown in the example, where a string is combined with an integer variable called age. This limitation often causes confusion for beginners when they try to display text along with numerical values. To solve this issue, Python provides a powerful and clean feature called fstrings, which were introduced in Python 3.6. Fstrings allows us to embed variables and expressions directly inside a string. By simply prefixing the string with the letter F and placing variables inside curly braces, Python automatically converts and inserts their values into the text. F-string placeholders are powerful because they can contain any valid Python expression, including arithmetic operations, function calls, and formatting instructions. This makes F-strings both flexible and expressive when generating dynamic output. In the first example, F-strings are used to perform calculations directly inside the string. The next example demonstrates the use of format modifiers. Finally, the slide shows how methods can be called directly inside F-strings. In Python, certain characters such as quotation marks can cause syntax errors when used incorrectly inside strings. To safely include these characters, Python uses an escape mechanism where a backslash is placed before the character that needs to be inserted. The problem shown in the slide occurs when double quotation marks are used inside a string that is already enclosed in double quotes. Python interprets the inner quotes as the end of the string, which results in an error. This is a common mistake when beginners try to include quoted words directly in text. The solution is to use escape characters. By placing a backslash before the inner double quotation marks, Python understands that these quotes are part of the string content and not string delimiters. As a result, the program runs correctly and produces the intended output with quotation marks displayed in the text. Now let's summarize the content through a cheat sheet. Cheat sheet acts as a quick reference for Python string syntax. It summarizes core concepts such as string creation, indexing, length calculation, and slicing. It also highlights common operations like concatenation, repetitions, case conversions, cleaning, modification, splitting, and formatting. Together, these slides reinforce the idea that mastering strings is a key step towards writing confident, efficient, and expressive Python programs. So let's open Jupyter Notebook, write some Python codes together, and bring the concepts of Python string concepts to life. Thank you.